Budapest Waste-to-Energy Plant. Introducing the Budapest Waste-to-Energy Plant. In a proposal dated the 9th of November 1904, the Metropolitan Engineering Office respectfully recommends that, in contrast to previous procedures for dealing with garbage, the esteemed Municipal Council should proceed to set up a waste incineration plant, primarily due to the benefits in hygiene and perfection of disposal provided by such plants. This proposal was made more than 100 years ago. Back then, professionals were already well aware that household waste could be burned to produce steam, which could then be used for heating and lighting. The proposal also refers to the need for fewer horses and less fodder, due to the shorter transport distance required once the central incineration plant is built. In 1976, the decision was made to establish a waste incineration plant in order to solve the long-term issue of waste disposal. The facility was implemented as a major public investment in District 15 of Budapest, Rákospalota. It had a capacity of 350,000 tons per year.
The waste recovery plant, commissioned in 1982, complied with the regulation at that time. In recent decades, however, environmental standards have been significantly tightened. Therefore, a new flue gas cleaning system had to be installed. Logically, along with the construction of the flue gas cleaner, we also wanted to take the opportunity to modernize the boilers and combustion equipment in line with the state-of-the-art technical standards.
In December 2002, planning began for the construction of the flue gas cleaning equipment and the reconstruction of the boilers at the Budapest waste recycling plant. This was one of the largest environmental investments in Hungary. The main contractor was the German company Lurgi-Lengyes AG, and construction was carried out by Erbe Energetika Mérnökiroda Kft., a Hungarian firm. After the completion of the project in autumn of 2005, the capacity of the plant allows for the thermal utilization of 420,000 tons of municipal solid waste per year. Let's take a look at how this plant works. First, the incoming waste transport vehicles are weighed, and the amount of collected mixed municipal waste is registered. Selectively collected waste materials are recycled. Next, the specialized vehicles roll up the ramp and dump the waste into the closed 10,000 cubic meter waste container. From the gates, two 10-ton polyp grab bridge cranes pick up, deposit and homogenize the waste, then feed it into the hoppers of the boilers. One grabber can move approximately half of one vehicle's waste at once. Cranes are equipped with scales to continually measure and record the amount of waste delivered to each boiler. The boilers extract the air needed for combustion from the bunker, so the dust and decomposition gases produced during waste disposal are not released into the outside air. Inside the hopper, the waste slides down to the feeding table using a gravitational system. Next, a hydraulic feeding piston pushes it into the combustion chamber. The waste is incinerated on a 30-degree sloped grate system consisting of 6 cylinders expressly designed for this purpose. The rotation speed of each individual grate cylinder can be adjusted separately using a continuous stepless scale. The amount of air required for combustion can be regulated separately for each cylinder. Secondary air is blown from both sides into the upper part of the combustion chamber, thereby ensuring the perfect combustion of combustible gases, especially carbon monoxide. The waste burns perfectly at 1100 degrees Celsius on the grate inside the combustion chamber. The slag, making up approximately 23% of the original weight, falls from the last cylinder grate into a water bath, where it is cooled and granulated. Next, it is transferred to the slag container. Slag removal uses a closed, evaporative water cooling system, meaning that no wastewater is discharged. The slag management system uses electromagnets to separate waste iron, which is then sold for resmelting. Iron-free slag is used in municipal waste landfills as covering material. Firing is fully automated with computerized process control, which is supervised from the control room. For waste with lower calorific value, the minimum flue gas temperature is ensured via the operation of 2 stabilizing gas burners and 2 power burners as needed. At least 850 degrees Celsius is required for waste feeding. The aforementioned gas burners automatically switch on when the flue gas temperature drops below the specified value. An aqueous solution of urea is injected into the boiler chamber through the nozzles installed in the upper portion of the first stage in order to reduce the amount of nitrogen oxides. The amount of urea is controlled by the nitrogen oxide concentration measured in the purified flue gas. The flue gas exiting the boiler at 200 degrees Celsius first flows through a structure called a double cyclonic vacuum, which performs the preliminary separation of solid material, fly ash, from the flue gas. It has an efficiency of approximately 90%. The acidic gases are then neutralized by injecting lime water into a different apparatus, the absorber. Lime milk is added based on the concentration of hydrochloric acid and sulfur dioxide measured in the purified flue gas. Additionally, water is injected into the process for controlling the ideal temperature. Subsequently, activated lignite coke is added to the flue gas leaving the absorber in order to bind other compounds and gases such as dioxins, furans, and vapor phase mercury. The residual fly ash and the salts formed during the neutralization process are separated using back filters, and the dust layer forming on their outer surface is removed with quick blasts of compressed air. The variable speed flue gas fan transferred the purified flue gases to the 120-meter chimney. All 4 boilers have an emission monitoring system. Various pollutant components are continuously measured and recorded. The boiler ash collected in the funnels under the boilers and the fly ash separated in the cyclonic vacuums are then transferred to the fly ash silo, first by mechanical and then by pneumatic means. The solid residue collected in the back filters is then likewise transferred to another silo. Each of the 2 fly ash silos and the 2 residue silos have a volume of 290 cubic meters. Residue from the flue gas cleaning is transported in closed containers in dry powder form to a hazardous waste disposal site for professional disposal. The steam produced in the boilers at 40 bar and 400 degrees Celsius is used for electric power generation and district heating. One of the turbine generators has a rated electrical capacity of 24 megawatts, while the other has 3 megawatts. Any excess electric power not used by the plant itself is fed back into the national grid. This excess covers the annual electricity needs of 50,000 households. The steam released from the Budapest Waste-to-Energy Plant, in addition to heating the neighboring film studio, is also transported to the residential areas of Káposztás megye and Újpalota through a heat exchange center, where it provides district heating for about 15,000 homes.
Thanks to the new flue gas purifier, the Waste-to-Energy Plant is now fully compliant with the environmental regulations of both the European Union and Hungary. In addition, the reconstruction of the boilers has significantly improved the energy efficiency of the plant. There are currently around 450 power plants burning communal waste in Europe. Our Waste-to-Energy Plant is the only one in Hungary, but it is among the largest 25-30 incinerators in Europe.
This waste-to-energy plant is a special power plant that uses mixed municipal waste as fuel. It is called a waste-to-energy plant because we produce steam and electricity by utilizing the calorific value of the waste. Even only taking district heating into account, we save 16 million cubic meters of natural gas every year. A waste-to-energy power plant is an alternative source of energy that requires minimal use of fossil fuels extracted from the ground. The carbon dioxide produced by burning biomass will not negatively impact the atmosphere or contribute to the greenhouse effect, because the carbon dioxide produced will be absorbed back into trees and plants. As a green energy source, the waste-to-energy plant is equivalent to 12 wind turbines or 2 hydroelectric power plants similar to the one in Kisköre.
We only have this one Earth. It is our duty to protect it. By using thermal waste and other renewable energy sources, for example wind, solar and water, we can significantly reduce the amount of fossil fuels that need to be extracted from the ground. Modern facilities emit climate-neutral carbon dioxide, meaning that do not contribute to the greenhouse effect. On the premises of the Budapest Waste-to-Energy Plant, guests can also visit the Museum of Public Waste Disposal, which is the only one of its kind in Europe. Visitors can see the waste disposal documentation, as well as the street cleaning and waste transportation vehicles of olden times. The plant and the museum can be visited upon prior registration. Become our partner. Let's work together for our environment.